take a look at key features of a graph. We have this function f of x, and it's the graph here for us. We're going to use that to answer the following question. And some of this might be review from round number 1, which is good. So it's good to review, and then some of the stuff is a little new. Well, let's take the y-intercept. What is the y-intercept of a graph? So the graph crosses what? Y-axis. So there's what's crossing the y-axis. Where is that? 2. It's really important. The y-intercept is a very specific point. So how do we say that point? We know the y value is 2. What's the x value? 0. And it's always going to be 0. At any y-intercept, the x value is always will be 0. Okay? State the x-intercepts of this function. Well, kind of similar to y-intercept, it's where the graph crosses the x-axis. Well, it's crossing here, and it's crossing here. What are those 2 points? -6. The y value on an x-intercept is always what? 0. Okay. The other one would be 4. What is the alternative name that we give x-intercepts? You will hear this a lot. We call them zeros. Reason is they make our function 0. If this graph was represented with an equation, and we took -6 and plugged it into that equation, our answer would be 0. That's why they're called zeros. They make our function 0. Questions over that? You might also hear them be called solutions, things like that. Zeros. What's your name? More questions? First, it says over the interval -1 to 2, is this function increasing or decreasing? Okay. Remember, we read things in math like you would read a sentence in English. So we read it from left to right. You wouldn't open a book and read it backwards. You wouldn't read it from right to left. That would be really hard to figure out what the words are. And those really be words technically, because you're reading from the right of the word over. Okay, you have to read it from left over. Okay, so we're going to go to -1. Here's -1, where x is -1, there's an x right there, to where x is 2. And we have to decide, well, are we increasing or decreasing? So if we're reading this from left to right, just follow the graph. We just follow the graph. What does it look like we're doing? Does it look like we're increasing or does it look like we're decreasing? Yeah, what makes you think you're increasing? You're going up, right? You would be increasing for that reason. We're going up. And I like to think of it, we're going up a hill. You're climbing up a hill, meaning you're increasing your height. Okay? We will be increasing. So we can tell if it's like we're going up a hill. Going upward. Issue with it reading it from right to left, and you read it from right to left, well, it looks like you're decreasing, it looks like you're going down. So you're wrong. If you read it from left to right, you're actually going up. Questions? Here it says, give the interval over which this function is greater than 0. Okay? And what did we say f of x? What's a fancy form of? Y. So this is kind of asking, when are our y values bigger than 0? Okay? Well, just follow your graph. We follow our graph. What are our y values here, starting out? Are they positive or negative? Negative, so they're less than 0. less than 0, less than 0, less than 0, less than 0. Oh, what are they right here? 0. Well, that's important. What are they now? They're positive. They're still positive. They're still positive. We follow our graph. We still have positive y's. We still have positive y's. We still have positive y's. Oh, what now? What's our y value?
0.
0. Now what are our y values? Negative. Okay? So anything below the x-axis, our y values are negative. Okay? So we want to state the interval for which all of our y values are above the x-axis, or positive. Okay? When did it start to change? At what x value? Here's negative, 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 negative. Right here it changed. Negative 6. Okay? It stayed positive for a while, and then what did it start to change again? Positive 4. Okay? That's the interval over which our function is positive. Okay? When we do this, we write it as the x values. We're saying what x values make this function positive, meaning which x values give us positive y values. Okay? And we just fill in that in the middle. So from starting at negative 6 and ending at 4, our function is positive. It's above the x-axis. Okay? And that can be a little hint. Above the x-axis. If it's below the x-axis, then it would be negative. It would be less than. Do you notice anything? Do those numbers look familiar to you? Negative 6 and 4? Yeah, they're the X-Intercepts. That's a little shortcut. Then ask, when is this less than or greater than 0 or equal to 0? There you go. Your x-axis, X-Intercepts pretty much give you your answer. Okay. So your graph changes from being positive to negative and vice versa. Questions over there? Right, to state all the x-coordinates of relative maximums and relative minimums. This gets really tricky because we think maximums are all high points and low points. You are right, but there's something special about the relative ones. I like to think of them as turning points. Your high turning points and your low turning points. Okay? And there's a change in direction. Your hills and your valleys. If it's not a hill, if it's not a valley, then it's not relative max or relative min. Okay? So if we look, where is the top of the hill? What point? What is it? 2, 8. Who's the top of the hill? If it's the top of a hill, is it a max or a min? We're going to call this a relative max. Okay? Where's the other top of the hill? What other point? Other point is the top of the hill. Right? 6. And against the top of a hill, so when it's a do you have any more tops of hills? Nope. Did we say, oh, there's that. Okay, let's look at our valleys. Someone give me a valley. Think of a bottom of a hill. Good, negative 1, 1. That's that right there. And if the bottom of the hill is a valley, then we say this. Where's another bottom of a hill or a valley? Yeah, 5, maybe 2. That guy right there, relative min. Oh, does it change direction at all? Is it a turning point? No. Okay? that gets tricky with that, with these. Because we think it's a low point, so it has to be a relative min or relative max. Nope. Because if it continued a little bit, kind of how this guy, how it continued, yeah, that's a min. If it didn't, if this guy was gone and it just stopped, we wouldn't have written that one. Okay, it has to kind of be a U shape, either upside down U or right side up U. It has to be part of a U shape, a change of direction to be relative max or min. Questions over there? I'll think of it. Okay, questions? Okay. For x's, what are the absolute maximum and minimum values of this function? When it says the word absolute, that is high points and low points. Your highest point and your lowest point. When it says absolute, that means it doesn't have to change direction. It's literally what your high point is, and it literally is what your low point is. It doesn't have to be on one of those terms. Okay? So if we look at our graph, what is our highest point? Okay, so that would be, if it's our highest point, would that be our max or our min? That would be our max. Okay? What's our absolute lowest point? Okay, 5, big 4. And because it's our lowest point, it's going to be our absolute min. Questions over that? Our highest point is 2, 8. Our lowest point is 5, -4. And you look at it based off the y value. Questions. So if it's relative, you're literally just naming the turning points. Where am I changing direction? Top of the hill, bottom of the hill. Right? If it says absolute max or min, it's literally the what is your highest point on your graph and what is your lowest point on your graph. Okay? Questions over there? Here is, wait, what have I put? Oh, that should be -5. What is it? 1, 2, 3, 4, 5, 6, 7. -8. Thank you. -8. What's that? Okay. Questions over there? Okay. This was just on your quiz. What's the domain and range of this function written in interval notation? Okay? Again, what is your lowest x value? What's your smallest x value if you look at your graph? Yes.
Get a boy and a Wally.
What is your smallest x value? Smallest x value. What are your Good. -8. Smallest x value. So that goes first. What is your biggest x value if you look at your graph? Your biggest x value. Okay, very good. 6. And we have nice close points around both. So I have to put around them. There you go. Do the same thing for the range. You look and see in your graph, what is your smallest y value? Again, range represents y. Smallest y value. 4. What's their biggest y value? 8. And what are we going to put around both? There's a little shortcut regarding your range. Those numbers look familiar. There's the y values of your maximum range. Questions over there? I know they're a little long today, but you don't have homework. Compromise. You don't get homework. Just do your homework tomorrow. Okay. Just hang in there. Got a few more. Alright, so it says if a second function d of x is defined by the formula d of x equals 1/2 f times x plus 2, then what is the y-intercept of g? What did we say the x value is at every single y-intercept? 0. So what are we going to plug into this guy right here? 0. So we're going to say e of 0 is equal to 1/2 f of 0 plus 2. Plug in 0 for x. Well, what is 0 plus 2? It's really tempting to say, oh, 1/2 times 4 is 2. I don't know why I did that. I know. Did I try again today? What's my number? My play. So maybe that's not. It's really tempting to say, oh, 1/2 times 2 is 1. Here's the thing. That 2 is trapped in the parentheses of that f. Okay? Think back to pretend that 1/2 isn't there. Function notation. We need to evaluate what f of 2 is. We'll go to our graph. Go to the x value of 2. And what's our y value there? 8. So this f of 2 now becomes 8. And is what is 1/2 times 8? This is what I was looking for. That's why I wrote 4. Please. Jumping ahead. Questions over there? Hold over. Graph the function. Already done. Did it for you. We just want to state the domain interval over which the function is decreasing. So we said increasing was going from low to high, so decreasing would be going from high to low. Okay, we read our graphs from left to right. And it's really convenient because we start at a high point right here and we go to a low point. Whenever you're stating intervals over where something's increasing and decreasing, you're always going to use this little notation. Every time. You notice we never put lines underneath these inequalities. We didn't do that on the front either. So think about it. Think we're climbing down this hill. Okay? Start at the top. We're just standing there, right? Our elevation isn't decreasing. Our elevation isn't increasing. We're just static. We're standing. Okay? And you follow or roll or walk down the hill. Whatever you prefer. And then we land at the bottom. When you're at the bottom, you're static. Okay? Your height isn't increasing, your height isn't decreasing, you're just there. Okay? So your start points and your stop points aren't included in your increasing and decreasing. You're not really moving at those points. You're just starting and you're stopping. Okay? So never put lines underneath those. Because their start points and stop points are not included. Okay? Well, where are we starting at? What's the top of our hill? Percent. What x value? Where are we starting at? Negative what? 4. Where are we stopping at? We start here, we fall down, and we end up 1. That's where it's decreasing. Because once we hit 1, we immediately start going back up. I don't know. Okay. What? We'll get more practice this one. For C, state the zeros of the function on this interval. Well, again, we said zeros were the what? Talk about this function. X what? Yeah, X-intercepts, X values. So what are our two X-intercepts? What's across the X-axis? And?
-3.
Good. And where else? Yep. Very good. Questions over that? And then state the interval over which g of x is less than or equal to 0. Oh, come on. I'll have this all grouped. You know, grouping. Sorry. Just say the interval over which this function is less than or equal to 0. We're still going to use this nice little notation. If you notice, there is a line underneath the inequality here. So what do we need to put under our inequalities in our notation? A line. This will indicate to you what inequality you're using. So if there's no lines, you don't put a line. If there is a line, you do put a line. So that means equal to 0. So our intercepts are included. And we said that shortcut would be to look at the X-intercepts. What's our smallest X-intercept? What's our biggest X-intercept? 5. There you go. Okay? Because we want to know where this function is equal to 0. Well, it's equal to 0 at our first X-intercept. And then if we follow our graph, we're following our graph, we're following our graph, we're following our graph, this is where we have all of our negative y values because it's below the x-axis. So we go from 1, 0 to the other, and that's where it's negative. That's where it's less than 0. Below the x-axis. Questions over that? I'm not worried about this one right now. Don't worry about that one. Are there any relative maximums or minimums of the graph that show what are their coordinates? Do we have a maximum or a minimum? Minimum. Yeah, we change direction at a low point. This was a min. And what is that min? What's that point? -8. Our low point. So our graph changes direction. And it looks like if it was curved, it'd be the bottom of the hill or a valley. So it's a min. Questions over there? One last thing. We're given this table, and the domain goes from x value of -6 to x value of 13. With the selected value shown below, the function has exactly 2 zeros and exactly 2 turning points. One at 3, -4, and one at 9, 3. We want to state the interval over which the function is less than 0. Again, we're using that shortcut. Our x is in the middle. Are our inequalities going to have lines underneath them? No, because there's no lines underneath there. Always do that. And then what goes at each end? What part of your graph? The x-intercepts. So look at your table to find your x-intercepts. Okay? What's the y value at every single x-intercept? It's 0. And again, we said f of x, a fancy form of saying y. Okay. Well, we have a 0 here and a 0 here. Those are our 2 x-intercepts. Which one's the smaller one? That's going to go first. Which one's the bigger one? That's going to go second. Okay? And as you can see from these numbers, our y values are negative. They're all less than 0. So between these two numbers, we have a negative function. F of x is less than 0. It's negative. And we state the interval over which f of x is increasing. Okay? Those turning points are going to help you out. Okay? If it's increasing, are we going from a low point to a high point or a high point to a low point? Low to high. Okay? Think about these turning points. Again, we're dealing with increasing or decreasing, so we always use this notation every time. If it says is it increasing or decreasing, that should be the first thing you write down. And then figure out what numbers go where. So if we're looking at these points, because you always go from one turning point to another when we're talking about increasing and decreasing. Which one's lower? 3, -4 or 9, 3? 3, -4. So you just take the x value of that turning point, and that's going to go first. 9, 3 is higher, so you take the x value of that turning point, and that's going to go first. You don't even really need to look at a graph. If you look at the table, though, we're starting, if we go from 3, our numbers are getting bigger. Okay? Once we hit 9, our numbers start to go down again. That means we started low. Okay. More practical tips tomorrow. Questions? Other things? I don't know.